In this video, I'm going to show you how to actually program your first random bot. I really recommend you to follow what I do and not only watch, because I just recommend it. Okay, so let's start. First, as it's random, let's import a random module. We'll certainly use it later. Then the bot name. Let's call it my random bot. Random bot. And we'll define a global variable. Let's call it board, which will be a two-dimensional array of empty strings. That will initialize a matrix of 909. Next, as we communicate with the engine using A, B, C, D, E, and on, but we get the board at indexes 0, 1, 3, 2, 4, and on, we'll need a function or an array to convert one to the other. So let's make a function to convert it. Let's call it chart to index. No, let's make it shorter. Index char lambda c just a moment. Well, okay. Index to char. Okay, I was thinking the opposite way and got confused. So index to char will be A, B, C, D, E, F, G, H, I in the index C. I hope I can do that. I think I can. If it raises an error, we'll see. Char to index is lambda C. A, B, C, D, E, F, G, H, I. Index C. I hope. Let's try to verify it is that way. Python A, B, C, D, E, F, G, H, I, index G, 6, and that's right actually. But note that is raised an error if the character is not there, so we'll have to be careful with that one. Char to index and index to char. Next, let's start to make our handle info. When we handle the info, we also reset the board, so we'll copy that line here. Of course, we will declare a global board because we don't want to mess with method private variables. Okay, so in the previous video, I told you that it's very important to actually click connect every time you start a new game. But why? Because connect calls that function of handle info, and usually we initialize the variables in that function in the handle info. So it's very important. Remember that. Okay, I think it's okay for now for the handle info, and we'll return, of course, instead of sample Python bot, we'll return bot name, which is my random bot. Now in the handle turn function, let's start with getting the board and square. So of course global board, like that. Board B, we'll call it. Char to index, opponent move 0. If opponent move 0, no, you know what we'll do? Find. That way it won't raise an exception and everything's good, I hope. Let's see that it works. A, B, C, D, E, F, G, H, I. Dot find F. Works, and find T also works without an error but a -1. Okay, so we'll use find. So B is char to index opponent move 0, which is the opponent move board, and S, like square, is char to index of opponent move 1. You can always assume that the opponent move has 2 characters exactly. The opponent move square. Okay. Now let's place the board and square on our board global variable so we can actually remember the state of the board. So if B is not 0 and S is not 0, not 0, of course, -1. If it's actually on the board, so board BS is O. Let's assume we're X and the opponent is O, but it really doesn't matter because it's only a way for storing. Of course, it can be O and M, like opponent and me. It can be A and B. It can be everything. But let's mark the opponent as O and myself as X. Okay. Next, we're going to what does this do? That's next. Okay. Now we're going through the possibilities. So let's make a list of possible moves. Okay. For now, let's just iterate through the board and just add all the possibilities. So, for I in X range 9, it's 9, it can be range. Of course, X range, the bot API works in Python 2.7. Just a reminder. Then we iterate through the squares in the same board. Then we say if board IK is not captured, possible moves append. Let's make it a string, like 2 characters. So index to char I plus index to char K. So it would be something like AB or GE or something like that. Now we'll select the move index. Move index will be a random integer, like randint, from 0 to the length of possible moves, -1. Actually choose a random move out of all the possible moves. Then we move is possible moves, move index, and we change the board variable to represent where we put our marker. So board chart index move 0. Not the smartest way to do that, but you'll think of a better way later. Move 1. So we put that an X to mark that we made a move, and we return the move itself. Now, of course, it's not the whole bot, but let's try to run it. Samples Python, where we put our new random bot. New random bot by. No, what did I do? Of course, you probably noticed it before me, right? Still not random. Okay, that seems good. Let's run it against random bot. We run it on 8086. So 8085 will be our bot, my random bot, and 8086 will be the sample Python random bot. Let's try to run it and see what happens. Okay, so it says bot1 has played in the wrong board. Why? Because we have to play in board A. So we didn't check where we have to play. Let's keep the random bot open and we'll stop our bot and let's fix that. So we'll have to check that the board we're checking is let's say like that. If I is not indexed to char, opponent no S. We basically check one thing. If the board we are currently iterating through is not the same number as the opponent's move square, so we continue. We'll check, of course, for the exceptions of free turn and the game starts. We'll check that also now. So if I is not that, and index to char S is not -1, means if it's not the start of the game, and the second possibility, the second exception, we'll check it later. Now, if it's not the right board and not the start of the game, because if it is the start of the game, we can play in any board we want. So let's try to run our bot again and see what happens. So we'll connect and start. Let's do that in debug mode. Invalid response. What have we done? You know what? Let's print it. Print move. And see what happens. No, it's not that one. It's that one. Oh, okay. Exception. Let's see that. Just a second. Ah, of course. S is already a number. Of course, we don't convert it back to char. Oh, crap. Let's try it again. Your random bot, let's see. Connecting, okay, start. And we have put our marker here in square 7, board 3. Step, let's make the Python random bot to make it smooth. It will play in that board, played here. So now if our checks work, we should play in that board. Step, and here we have put our marker here. Now step the Python bot will play here, then we play here. Now let's remove debug mode and let them play together until another exception is raised. It will happen. Just a second. There we go. Just a second. Bot 1 has played in an inactive board. What it means, I think the last move of the Python random bot was that square, if I remember it right, and it sent us to that board. But that board is already captured, and though it's inactive. So we've tried to play in an inactive board. So now let's make the check of an inactive board and try to avoid playing in such boards. First, we have to check if a board is active or not. So a regular board is represented using a 9 characters array, like that. Okay, so that represents an active board, which has 8 squares. Now, assuming a board is not active, which means captured, it has one state. Actually, it's all of the board is X, is counted for the X, or everything is counted for the O's, or it's tied. Tied is not counted for any of the boxes. So we can make a capture board be only one character, like X if it's captured by X, O, or T if it's tied. Let's make a function that tests whether a board is captured or not. Is captured. Now let's try to test something. If we have the 9 strings array, let's make it free, and we run len on it, it returns free. But if we have a captured array, like X, it will be 1. Is captured, so return that is captured. And we get a B like the board, len B is 1. And we can make it even further, return B if len B is 1, else nothing. This means that the board is not captured by anyone. Otherwise, it will return T, X, or O. We can also return false. We'll see what makes better performance or what gets along better. So, this one checks if a board is already captured. But how do we check if a board should be marked as captured? First, let's check a function that will check a line. Check line A, B, C. These are the 3 elements of the line, like that, and that will be argument. Sorry, that, and that, or that, and that. We'll set it 3 parameters, and it will return the appropriate letter if the line is captured by X or by O. So, if a, just a second. Okay, let's make it a bit different. get a board parameter, and these will be the indexes. So it can be 1 to like 1, 4, 7, meaning, I'm sorry, 1, 4, and 7. Sorry again, 1, 4, and 7. These, or 0, 1, and 2. It will get a board and 3 indexes. So is X and bow B is X and bow C is X, we return X. Otherwise, if it's O's, return O. Otherwise, we return nothing, because the line is not taken by X nor by O's. So we'll return an empty string. Now let's define another function which will be checkboard bow. That function will check every line of the board and will return X if X1, O if O1, T if it's tied. Tied means it's completely taken, there are no free squares, and no one won. Or empty string if there are still 3 places and no one has won. So, firstly, if is captured bow, return is captured bow. So if it's captured, return who captured it. Otherwise, we have to check line and actually see who won. So what we're gonna do, yeah, let's do it like that. Okay, so we have to check if check line board 0, 1, 3, 0, 1, 2, which means let's remove all this fluff. If 0, 1, and 2 is X, or check line, then we have 3, 4, 5, which is the middle row, 3, 4, 5, then we have 6, 7, and 8, which is the bottom row, 6, 7, and 8. Then we have to check the columns also, so it's 0, 3, and 6, or it's 1, 4, and 7, or it's 2, 5, and 8. 0, 3, 6, 1, 4, 7, 2, 5, 8. We check the columns now. Now let's check the 2 diagonals, which are 0, 4, 8, or 2, 4, 6. So 0, 4, 8, or 2, 4, 6. So if any of these conditions is met, we return that the board is captured, should be marked as captured by X. So, as I said, if any of these conditions is met, we return that the board should be marked as won by X. So, if it's O's, if one of the rows is captured all by O's, we return that it's O. If we have reached here, it means the board is not captured by X nor by O. Now we have to check if it's full. If it's full, it's tied. If not, it's still open for new moves. So if the board in bow we don't have that, we can use a temporary. We return T if there is no free place in board, else we return nothing. Right? Yeah. So this is the checkboard function. I hope it works. We'll check that later. We have the check line function. And yeah, we basically have to use that. So now, if B is not -1 and S is not -1, it means that we updated the board. So let's use this to check if the board is, if any of the, I think, nope, not here. Let's check it anyways. So we're gonna iterate through all the boards and check if the board is captured or not. So for I in range 9, if checkboard, no, let's say if board I is in X O T, which means if it's tied, it's captured by X or by O. We don't have much to do that, so we continue. Otherwise, if checkboard board I, oops, in X O T, which means if we check the board and it should be marked as captured, because the only possibility that it should not be marked as captured is an empty string. So if it should be marked as captured, so board I would be checkboard board I. Otherwise, we don't touch it, we leave it as it is, as a 9 elements array. Basically, that line would transform it from a 9 elements array, from that one, to basically that one, X, or O, or T. Now, we'll have to iterate and check that we're not hitting boards that are actually captured. So, to check if a board is captured or not, we can use our predefined function, is captured. So, if I is not S, if the board we're checking is not the correct board, and we are not in the first turn, and not is captured, board S. And if the board we should play in, board S, if it's captured, we can play at any board. But if it's not captured, we'll have to check the others and see that they're also at, then we just continue. We don't add that board to the possibilities. Let's try to see if it runs now. We'll try it again. Nope. What's now? Or, of course, like that one. Don't do that. Still not? What have we done? If check line bow 0, 1, 2, or should I do that? Yeah, okay, it's working. It works now. Connection is okay. Connection is okay. Let's start and see where it fails, if it fails. And we got a square and second. And we're not good. Something happened. Okay, so we have forgot one important thing. That if we're iterating on a board that is already captured, we can't possibly play there. So we have to add if is captured board I continue. Let's try it again and see if it works. As you can see, we continue to generate more moves. And the game that thing. Oh, and we got our first board. Second. Third. Oh, and we won. We have a row of D, E, and F. So we won. Let's try to run our bot again just to make sure it works. And as you can see, it plays really well. Actually, not pretty well, but pretty randomly. And that's it. That's our random bot. And sounds like we got a square. Second one. And we won again. Pretty good bot. So, well, what have we done in this video? We have made a simple random bot in less than 100 lines that actually generates all possible moves and picks one of them. If you want, you can write your own bot. You can build your bot upon this code. This code is actually also in the random bot example, but I will keep the new random bot example also there if you want. Basically, it's a pretty simple code. I don't think it's hard to understand it. And if there are questions, of course, feel free to ask, comment, share everything you want to do. I hope you understood, and ciao, see you in the next video.